Hi everyone, welcome back to my channel. In this video, we are to learn discriminant. Before we look at discriminant, let's try to use the quadratic formula and solve the x for this question. So I've done that for you, and we just need to simplify. So minus b, you get minus 4 plus minus, at the denominator, 2 times 1 gives you 2. I would like you to pay attention on the expression that is under the square root, b squared minus 4ac. And let's start to simplify. 4 squared gives you 16, minus 4 times 1 times 4. So minus 4 times 4 gives you 16. So 16 minus 16 should give you 0. So you have 0 under the square root and square root. Now, let's separate the two x solution we have. I believe the first you have minus 4 plus root of 0 divide by 2. That's your x1. While your x2, you should have minus 4 minus root of 0 divide by 2. Let's look at x1 first. So let's simplify the root of 0. So root of 0 is 0. Minus 4 plus 0 is minus 4 divided by 2. That gives your x1 as minus 2. And let's look at our x2. You have minus 4 minus root of 0. So root of 0 again, that is 0. Minus 4 minus 0 is minus 4 divided by 2 gives you minus 2. If you are to look at the two solutions we are repeatedly getting minus 2. In other words, you have your x1 is equal to x2, only one repeated root in this case. And let me ask you, what causes the one repeated root? You may say, because I'm square rooting 0, so plus 0 and minus 0 is no difference. Absolutely. And let me ask you, what causes the 0 to be there? So you may say, is the expression under the square root that causes the 0. Okay, let's specify the expression under the square root, that is b squared minus 4ac. And this expression will determine the nature of roots we will be getting, and is called the discriminant. Moving on, we are to look at the nature of discriminant, that is b squared minus 4ac, the part that is under the square root. The first case, the most common, you have your discriminant greater than 0. That tells you you will have two distinct real roots. If you are to refer to the graph, you will see that there will be two x-intercepts, and each x-intercept represents a real root. The next case is when your discriminant is exactly equal to 0. So that tells you you will have only one repeated real root. If you are to refer to the graph, you see that there is only one intersection of the graph and the x-axis. The last case is when your discriminant is smaller than 0. In this case, you will have no real roots. The reason is we cannot have a real root answer when your base under the square root is smaller than 0. And by referring to the graph, you should see that there is no intersection between the x-axis and the graph. So that tells you you will not find a real root solution when your discriminant is smaller than 0. If you like this video, don't forget to subscribe.